I'm in the middle of a test, but I still wanted to make a little video so you guys could see kind of what's going on. I've put together a diagram at the big picture, you might say. This is in the tender, okay, and this is in the boiler. And here you'll see we have the transformer coming into track power going into our power distribution board, and then the power is going out to the various places. It's coming in through the wheels, and it's going in AC and coming out DC to the various places. One of them, of course, is the motor control board, which is in effect our digital reverse. We also have two other outputs. These are buck boost boards. This one is for puff and chuff, and this buck boost is for smart smoke. Smart smoke is pretty straightforward. It goes right over to the lid with the trim pot and all of the circuitry, the sensor and the heater and the chip, the LM317, to manage the heat, and we adjust that and set that as we go. The wires from the motor to the smoke come out of our puff and chuff board. The puff and chuff buck boost comes over here, and he actually supplies three different circuits: the idle circuit, the puff, and the brake circuit. And there's a trim pot for the idle circuit, and we run that at very low speeds, 3.5 on the puff, 2 and 0.3 on the idle. So it's a little idle thing going on there. So that's how the power comes in. It gets conditioned, goes through these two rectifiers to get converted to DC, and then it goes back out, and it does work through the reverse and through these buck boost boards. These are regulators. This one is set to 7 volts for puff and chuff, and this one's set to about 8 volts for the smart smoke. We also have a directional sensor. I don't know, directional sensor is power sensor. The motor control board goes into the drive motor through the brushes. But we also have a signal that we take out of this, and it allows us to fire a relay. There's the relay down in this circuit, and these two pins are what drive that to fire as a relay. And I had a lot of trouble with that relay working for me because the relay, what it does briefly, this is the power circuit for the puff and chuff. This is puff, this is brake, and the energy from these all come out to this pin. So this is puff and brake, this is idle. And this relay determines if the motor's not running, it drives the trim, the idle from the trim pot down to the motor. If we're moving and the engine and the motor's rotating, we sense that, and then it triggers this to flip to this pin and drive that circuit down, and that circuit oscillates based on the limit switch settings from puffing the fan to braking the fan. Puff, brake, puff, brake, puff, brake. That's how that works. So I have to make sure that this cycle here actually works with all of the load that I have on the engine, the power distribution board, the track, and the transformer. I've been having trouble with this thing maintaining reliable operation. And so what I've done is I've set up an experiment where I'm running my transformer at about 5 volts, just below 5 volts. I'm getting 30 miles an hour. It's actually moving, everything is moving, 5 volts. It's coming up through the track, up to my regulator, or my rectifiers, and they're warm, but they're not hot. Motor controller for reverse, and also the two buck boost boards. That's a buck boost board, this is a buck boost board. And I had trouble yesterday. Had a bad event, you might say. I was puffing and chuffing, and I fried the smoke. I haven't fried a smoke in a long time. That's the new smoke in there now. This is the one that was in there, and I think it's pretty evident I fried it. Not only that, it was interesting because the housing became hot enough that the housing opening where the smoke comes out melted closed. So wasn't getting any smoke out, and the heat was up, the fan wasn't running, the relay wasn't triggering, and I couldn't figure out what the hell was wrong. And by the time I thought maybe I should shut it off, I looked over and I saw smoke coming out of the board from here. Smoke, not good smoke, right? Shut everything off and just went upstairs. I was so kind of down. Thought about it, talked to a few guys, and I have some folks that still talk to me. It's pretty exciting. Anyway, Dan has been super, you know, and straightening me out. Get back in there. Come on, we got to figure this out. So I set up this system now. There's the track. There's the transformer power, and it's at 5 volts. I just measured it. And I have AC coming in and DC coming out of this guy. This is our power distribution board, and there's a couple of wires that go down to this boy, and he's our reverse motor. It's warm, but it does run warm. It's not hot. And I set up the buck boost boards because I wanted to have some kind of load. I wanted to make sure they were working, they were doing something. So I set them at about, I think 5 and 7 volts, something like that. And I just put a pair of motors on it just so I knew they were working. Fans running, I can change them and I can hear the pitch and and I can check the voltages and whatnot. I modified my diode blob because I felt the diode blob was actually doing the job. What I worried about was the volt drop with the diode blob. But what I found was right now at 30 miles an hour, we're getting 5 volts the engine can run. I'm thinking, you know, hey, you know, with these 2 buck boost boards working, running 2 fans, that's pretty good. I felt pretty good about that. I'm not plugged into my puff and chuff system yet. Now, the test today, the test right now, is to see if I can come off of this is open. 0.L means open line. Now, what I want to see is a closed line. See that? It closed, it's open. It's closed, it's open. Now, how I did that just now, when I held it from you to make it a surprise, we're running at 5 volts, running at 5 and 6 volts on the buck boost boards. Fans are turning, you can see them turning, you can hear them turning. The engine is running, the motor's turning the wheels, they're spinning on my beautiful rolling road. Andy, God bless you, beautiful job. And I take my blob, the new diode blob, which doesn't look like a blob so much anymore. I like it. I think I might do it. And I'm going to touch this wire to the opposite field of the relay inside this device. And when I touch it, now the circuit is closed. And I take my wire away, I put it on, I take it away. Now listen to the pitch. I didn't hear a change in pitch. The motor is turning the wheels, change in pitch, none. I did put a meter on. I tried to look for a volt drop, and it was in the maybe 0.25, maximum 0.5. It was a very small amount of volt drop with this configuration. Now, I don't have the full circuit board put in place, and I don't have this plugged into this reed switch, which is what I had. So I'm gonna have to think about it. Do I feel confident I can rewire this to take this energy from the diodes and send it back and trigger that properly? I think what I'm going to do is I'm going to set it up as a test run. I'm going to set it up and put it in there and see what happens and run it as a test. So there'll be clips and temporary solder joints and things of that nature. But what I can't figure out is Why does this change, or why did it change? Circuit, open. Circuit, open. And when I move my clip to the other lead, which is the, well, this is a puff. This is the puff lead. On the other circuit, it would be closed right now because that's just the way this works. When the engine is running, which it is running, this would be connected and the circuit would be open, and that means energy would be flowing from the puff brake circuit to the motor fan. So the motor fan will be going puff brake, puff brake, puff brake when this is energized now, and when the fan, when the drive motor's turning, then the fan would be puff brake during that period, that state, that mode. So it, you know, I've loaded it, I've wired it, I've neatened things up, I cleaned up a little bit so you can see the surface, and it seems like this will work as a direct without the reed switch. I'm thinking the reed switch may have been taking too much out of me, and I also was thinking taking power for the taking power for this relay from the puff circuitry might have been causing trouble, because if I go back here, you can see here Robert's initial design had power coming in from the VCC source and the relay circuit coming in from 12 volts isolated. So he didn't really intend for all of this to be wired in one fell swoop to the same spot. What I had been doing was taking this input, the 7 volts for puff and brake, running it here and running it to ground, and I'm thinking, you know, that's probably not smart. You're probably grounding the circuit and draining a lot of energy out of that puff and chuff. So now I've isolated it. Oops, sorry gang. Isolated it. I was doing so well and then I blow it, right? I've isolated that trigger for this, and then the circuit power should be coming in 5 volts and then trim pot on the idle to whatever it needs. Then, all right, so I think the next step is I'm going to get this guy back up and running the way it should run, and verify with my extra fan motors and stuff it's doing what it's supposed to. Like you saw here, when I hit the switch, you'd see puff and brake, and that was on 5 volts, right? That was only 5 volts. So, all right, I'm going to go back to this, continue this test, try to figure it out, and make sure I'm not overloading a circuit or creating a conflict somewhere in this distribution of power wiring schematic that I have going on. That's what I'm up to. All right, sorry for the long video, but I've been days doing this, and it's Friday. I need a win. Right now, just doing this with this wire for me. Oh geez, I just touched something there. See that? That's a win right there. That's a win. Now, if I do that through this board, and I also just isolate puff and idle, and I watch that turning off and on, and I can see that we go from puff to idle, idle to puff, just on the board without running anything else, then I'm okay. I feel good about that. Now then, one other thing I noticed, when I started to set this up, this was left over from the other day when I had the catastrophe. For some reason, my buck boost boards were way out of adjustment. I mean, they were cooking 20, 25 volts. I don't know how or what happened. I don't know, because I run tests. The only thing I can think of was maybe my input wiring was so hokey, just going all over, jumper here, jumper there, extra wire. I had so much inline resistance, I wasn't getting the full power. Right now I just have these 2 jumpers right from the track. I keep touching that fan blade with my finger. And I think I might have introduced some drop in the test layout. That's one of the reasons why I wanted to try to trim down the wire leads and get this more in a production looking environment. In fact, I'm going to fix these pickups so they're actually doing the pickup, and I'm going to run them through the trucks before I settle on I think I have it fixed or not. And that may be just have to do that this weekend. I don't know. But so far I'm feeling better than I did 2 days ago, better than I did last night. I've had some rough nights, guys. I dream about this. I think about it all the time. I can't stop. Fried a smoke lid. Smart smoke is not supposed to melt. That's why it's called smart. And boy, did I outsmart it. Man, I really tricked him. Okay, well, let's get back to it, and I'll fill you in hopefully today with some good news. All right, later.